Here we go. Okay, so how about this one? This one, it could be, I know, I think some people, when I look at this, I didn't look real closely, but I think a lot of people that missed it because they didn't do the question right. They didn't read the instructions. So what's this really asking you to do?
Isolate it.
No.
Simplify the fractions.
Okay, it wants you to just complete the square, right? It wants you to stop before you isolate x, though. It wants you to complete the square so your answer looks like that form.
Oh, immediately prior.
Prior to, there you go. Exactly. So on this one, let's just walk through this. What do I have to do to get this ready for completing the square? I gotta subtract 5. Good. I've got to get it in the form where I've got the x squared, start with x squared, plus some number times x, so negative 2x, equals, and then I leave a space, equals a constant, right? So we said before that that's the form x squared plus bx equals c, right? B and c are just numbers, okay? All right, so now I'm all set. That's where I start completing the square. And after one step, I stop. It's only a one-step process, right? Okay, what do I do? What's the first thing I'm going to do here?
Divide by 2.
I'm going to divide what by 2?
Negative 2.
Good. So I'm going to start off with whatever b is, right? I'm going to put half of b right down here. So half of negative 2 is negative 1. So Tyler, what's next? That's the first step. We'll label that step 1. Now what do I do with that? Right? That's the first thing, that's the first blank I fill in. Next one is I've got to add something to both sides. What's it going to be? Negative 1 squared, which is just 1, right? Okay, that's step 2. Okay, step 3. Gage, what do I do last? I wouldn't anyway yet. I still got to know what number goes on this side, right?
Negative 6. Or negative 4.
Negative 4. I get negative 5 plus 1 is what's left over on the right side. When I combine those, I just get negative 4. So that's where I stop in this case. If I were solving this, I would keep going. Then I would isolate x, right? But it's telling me not to do that. All it wants me to do is complete the square and then stop. So now we got it, right? This fits the form x plus a is negative 1 squared, equals b. B is negative 4, right? So that's what I'm going to put in Moodle. Okay? Make sense? Okay? All right, how about these guys? Let's see. Oh, something's... Okay, yeah, we'll do these. So, what about this one? This is different. Now I've got one where I've got both x squared and x's in it, right? If I've got x squareds and x's, I can't isolate x anymore, right? So what are my options?
Subtract.
Well, okay, I could complete the square. I think that's what you're going to say maybe, is get the 12 on the other side and complete the square. Maybe, right?
Yeah.
Okay, that is an option. That's fine. I'm going to say that probably the easiest and most reliable way of doing this stuff is just to use the quadratic formula. Okay? So let's remind ourselves real quick, what's the quadratic formula? So if I start off with a quadratic equation in standard form, so it's set equal to 0, which it is, right? So ax squared plus bx plus c equals 0, then the quadratic formula tells us that x equals what? Negative b plus or minus. Very good. Okay, so all I got to do is plug in values, right? So in this case, a is 1, right? B is negative 4. C is negative 12. And I'm just going to plug that stuff in. So that gives me x equals negative b. That's positive 4 then, right? If b is negative 4, negative b is positive 4. Plus or minus square root. B squared. What's b squared?
No, 16.
16. Okay, remember, when I square a negative, I always just square the positive, right? Then you can't make a mistake. You can make a mistake on a calculator squaring a negative. It's really easy to forget to include parentheses. Always just square the positive. So 4 squared is 16 minus 4 times 1 times, now watch this, times negative 12, right? Put the negative sign out front, which makes that a positive. See how that went? One more time. Isn't that a great little trick? So when I want to multiply by negative 12, instead of writing the negative there, just put it there and make it positive.
Wow.
Well, what if the
Wow.
one was negative? You couldn't count the four too?
Say it again.
So if like the one were negative, we put that
If the one were negative, yeah, then you would have to, you'd have to do that again. But remember what we always do. The one will never be negative because we always want to make sure that A is positive, right? We would have multiplied through by negative 1 first,
Okay.
right? Okay? And then all divided by 2A, well, 2 times 1 is 2. So all I've got to do is just simplify this, right? So I get 4 plus or minus the square root of 16 plus 48 is 64, if I add all that stuff up. So what's that give me? 4 plus or minus, what's the square root of 64? 8. 4 plus or minus 8 over 2. If I take the plus sign, 4 plus 8 is 12 over 2. 6. If I take the minus sign, 4 minus 8 is negative 4 over 2. Negative 2. 6 comma negative 2, right? We could have, and this is an option if you want to, you can always look to see if magic numbers work. And in this case, they did. Right? You can always ask yourself, if I have a 1 in front of the x squared, can I find numbers that multiply to negative 12 and add to negative 4? Yeah, negative 6 and positive 2, right? So I could also do this one if I want to. I could factor it. X minus 6 times x plus 2. And then what value of x makes that 0?
6.
6. What value of x makes that 0?
Negative 2.
Right? If it works, it's really quick. But it doesn't always work, right? Okay, that guy. One more of those, how about for practice? How about this one? What could I do with this one? Good. I don't have to, but it's going to make life easier when I use the quadratic formula, which I'm going to do, right? I'd rather make those numbers A, B, and C smaller, right? So this goes back to that assignment where I had you guys do some greatest common factors. We just want to find what's the biggest thing that I could undistribute from all those terms, and that's going to be what I could divide both sides by, right? Okay, so I could divide each side by 4 in this case, which leaves me 0 on the right side, and now I just have to do each term separately. 4 divided by 4 is 1, so I just get a plain old x squared. 12 over 4 is 3, good. And negative 4 over 4 is negative 1. So now I can just use the quadratic formula, right? And so x equals negative b plus or minus square root, b squared is 9, minus 4 times 1 times negative 1. And so what should I do with the negative 1? I didn't do it. Yeah, make it positive, okay? All divided by 2 times 1 is 2, 2a. So I get negative 3 plus or minus square root. 9 plus 4 is 13 over 2. And so I'll just split that fraction, and I can't reduce it anymore. That's going to be my answer. Negative 3 halves plus or minus the square root of 13 over 2. 1 for the plus. What's that?
What if you just left it as that?
Well, you can't put a plus or minus in there
Well,
anyway.
yeah, but you like put a
You
plus
could.
in.
It would be fine. It'd be fine this time because nothing reduces. But what if, like, that fraction had simplified and that one didn't, for example? Then that would have been only partially correct. So, which is why I think it's easier to just separate it every time. Okay? All right. Last two are just discriminant questions, and we're done. And you're ready to go. Okay, so oh man, we're gonna get done with this. How about that? Okay, these are quick. These are quick. Take a look. hang in there, hang in there. You got a whole weekend to just kind of not think a lot about this, but do some, not a ton. How about this one? The discriminant questions are easy. They're yes/no questions. That's it. The discriminant, remember, is just the part of the quadratic formula underneath the radical, right? So when we write out, let me just do this real quick. Okay, so real quick here, this quadratic equation in standard form, could I divide each term by something?
Yes.
What? 16 in fact. 4 would make it better, 16 would even make it easier. If I divide everything by 16, what do I get?
You get x squared
X squared
minus 4x plus 1.
equals 0. Okay, good? So let's check the discriminant. The discriminant is the part under the radical, right? So in the quadratic formula, if you just think of it this way, it's really easy to remember what it does. In the quadratic formula, that's the discriminant. So if I'm just checking the sign of the discriminant. If I plug in those values and that gives me a negative number because it's inside the radical, what does that tell me about my solutions?
It's a mansion.
They're going to have i's in them because I have a negative number inside the radical, right? If I plug in those numbers for b squared minus 4ac and I get something positive, no i's. But I am going to get, in that case, 2 solutions, one for the positive and one for the minus. So I'll get 2 real solutions, right? What if the discriminant is exactly equal to 0? If the discriminant is exactly equal to 0, I get b plus or minus the square root of 0, which is just 0, right? Well, think about that. Plus or minus 0 is not changing b. So I only get one solution, which is just negative b over 2a. So if the discriminant is 0, the plus or minus don't come into play, and I get one real solution. That's it. All I've got to do is just find the value of that, though. So what, for me, b is negative 2. So b squared is 4 minus 4 times 1 times 1. What's it equal? 0. It equals 0, so my answers are, you tell me, what are my answers then? What can you tell me about this? Let's see, Ariel, how many solutions? If the discriminant is 0, what am I going to get there? One real solution. Good. Perfect. Okay, now one other thing about this. I gotta go to the next one. No, I can't. Right there. This guy. Okay. So one other thing about this. If you think about where this comes from, remember it's a standard form. It's a quadratic equation in standard form. I gotta hustle. I can do this. So it looks like this, right? Ax squared plus bx plus c equals 0, right? We haven't talked much about this. This comes in Module 4, but you've done this in Algebra 1. What does the graph of a quadratic function always look like? Remember? It's a parabola. Good. It's always going to be an infinite U shape, right? And we'll talk a lot more about that later. But what I'm really doing here then is I'm saying, okay, I've got some quadratic function, y equals ax squared plus bx plus c, that's going to give me a parabola, and I'm asking the question, when is that function equal to 0? Meaning, when is its y value equal to 0? So real quick, where in the xy plane does y equal 0?
Origin.
At the origin, that's 1 point, but there's a whole line of points where y is always 0. The x-axis, yeah. The x-axis, right? So what we're really just asking then is, we're asking, where does this parabola have a y value of 0, meaning where does it cross the x-axis? In other words, where are its x-intercepts, right? So if there are real solutions to this, then they're gonna show up as x-intercepts on the graph, right? We can always make this correlation. Real solutions equal x-intercepts, right? So if I've got a parabola, like let's say like this one, that has 2 x-intercepts, how many real solutions does it have? 2. So what's the value of the discriminant? Positive, negative, or 0? Positive. Good. If I have a parabola like this one that only touches the x-axis in one place, how many x-intercepts does it have? So how many real solutions does it have? 1. So what's the value of the discriminant? 0. If I have a parabola that completely misses the x-axis, no x-intercepts, how many real solutions?
0.
So it must have instead 2
Imaginary.
imaginary solutions. There you go. Good.
Potassium bicarbonate, sodium bicarbonate, calcium